In this video, we'll discuss the risk manager's role in estimating the risk. That role is limited, but there is a real and substantive role that we've been discussing during this week in class. Basically, it's the risk manager's job to decide if a risk assessment is needed to estimate the risk. If it is, the risk manager has the responsibility to give that risk assessment direction and a realistic chance to succeed. The risk profile, which precedes the assessment, helps the risk manager to decide whether assessment is needed or not. If the profile produces sufficient information to make a decision, a risk assessment isn't even needed. If a risk assessment is to be done, the objectives and constraints and questions to be answered by a risk assessment give it direction. So let's have a look and see what was done here with our quantitative risk assessment case study. So I'm going to move this on down a bit, get it going here, and I want to stop here at the contributors, because one of the things that we're going to talk about is the importance of having a risk analysis process. This risk assessment was done by the Center for Food Safety and Applied Nutrition, part of the United States Food and Drug Administration. And they do indeed have a risk assessment process. You can notice here they have a team leader, a project manager, a risk analysis coordinator, scientific advisors, and then team members with specific responsibilities. What's important to note is that all of these roles have responsibilities spelled out for them, and they've all been thought about and defined by the Food and Drug Administration. Now let me just scroll on down a little bit to where we can find some of the materials that we've been talking about. When we talk about identifying the problems and opportunities, please recognize that this is the executive summary. You would actually find a more complete treatment of these ideas in the risk assessment that follows after the executive summary. But the problem is identified here in this kind of rolling dialogue. So you'll note this was conducted in response to 4 outbreaks in 1997 and 98 in the United States, with over 700 cases of illness from Vibrio parahemolyticus. They focused on raw oysters because that's the food that's primarily linked to this particular pathogen. And then it goes on to describe a little bit more about what was done. So we don't have that classic kind of list of problems and opportunities the way we've talked about. But to be honest, this is still a new developing concept for folks. So what you're seeing here is pretty typical of what's been done, at least at that point in time, from the late 90s into the early 2000s. Now, we get down here to scope and general approach, and I want to focus right here where it says the risk assessment had 2 main objectives. And this is as close as the risk assessment gets to identifying objectives and constraints. But I would like you to note that these are expressed as risk assessment objectives rather than as risk management objectives. There is a significant difference. But in this assessment, you can see they were intending to determine the factors that contribute to the risk of becoming ill from the consumption of pathogenic Vibrio parahemolyticus in raw oysters, and they wanted to evaluate the likely public health impact of different control measures, including the effectiveness of current and alternative microbiological standards. We've also talked about the importance of asking questions. And this is an area where I'm particularly pleased with this risk assessment, as you'll see in just a second. But as we continue to scroll down through the executive summary, I wanted to point out here are results. And one of the final steps in the risk manager's responsibility for risk estimation is to consider the results of the risk assessment. And that really is the subject of this particular video. The risk manager's primary responsibility in this regard is to make sure that he has received answers to the questions asked of the risk assessment and to assure that he understands the strengths and weaknesses of those answers. So here is what we would call a risk characterization. These results pull together all the work from the rest of the risk assessment in a way that addresses that probability and consequence. So if you look at summary table number 1, this would be important for a risk manager to understand. The rows are different regions of the United States, and the columns are different times of year. The table is showing the average risk per serving of oysters. So let's just take a look at that very first row, the Gulf Coast, Louisiana. In the summertime, this is saying that if you were to eat a serving of oysters, the expected probability of illness is 4 times 10 to the minus 4th. So 4 out of every 10,000 people eating oysters harvested from the Gulf Coast of Louisiana in the summertime could be expected to become ill. And that's a rather high risk. Take a look at the second risk from the bottom, Pacific Northwest dredged, and look over to the winter column. There we have 10 to the minus 10. So you can see there's quite a range in the probability of illness. And information like this makes it possible for risk managers to ban the harvest and consumption of oysters in certain parts of the country at certain times of the year. So, for example, eating oysters harvested from the Gulf Coast of Louisiana in the summertime can be banned to reduce the number of illnesses. If we scroll on down, continuing with the risk characterization, table number 2 shows the mean annual illnesses. Once again, if we look at the Gulf Coast of Louisiana in the summertime, we see an expected number of illnesses above 1,000, 1,406 people. If you look at the Pacific Northwest dredged during the winter time, it's slightly bigger than 0, but not much bigger than 0. It's less than 1 person would be expected to become ill. And so risk managers have the responsibility of understanding the risk. But we've also pointed out that it's very important to have those 3 pieces of paper: the problems and opportunities, objectives and constraints, and the list of questions to be answered. This is the executive summary, I would remind you, but you see here a notation that below are the responses to the questions that the risk assessment team was charged with answering. And you will see in bold the questions that were posed by the risk managers. And I am especially pleased about this because I was working with many of the team members here, and this was one of the key points that we were stressing as important to do. So you can see the questions, and in the bullet points are the answers that were provided by the team. So the risk manager, in considering the results of the risk assessment, needs to go through these questions in particular, read and understand the answers, and assure that they have the information that they need now to make a decision. Those results that we were looking at a few minutes ago, that's an important part of being able to make a decision. There is one other piece that risk managers are responsible for. You have briefly seen this model once before. A risk manager does not have to know how to build a risk assessment model. The risk manager doesn't have to understand how it's put together. The risk manager doesn't even have to be able to run the model. But the risk manager needs to know what the model is doing in broad strokes. And so the last time I oriented you to this model, we took a look at a simulation of 10,000 meals, and we were looking here to see what the the number of people who would get ill would be. And what I would like to point out now is that in this risk assessment model, they did evaluate risk management mitigation measures. So let's take this value right here. In the green column, we see that this person whose consumption is being modeled was consuming about 3.6 log per gram of oyster flesh of Vibrio. And if we follow that down through, we would see that this person ended up consuming 167 pathogenic Vibrio. They had about 10 to the minus 6 order of magnitude chance of becoming ill, and this person did not actually get sick. But what this model also does is it says, okay, let's take these oysters right here. Now, come on over here and let's suppose that they were subjected to a heat treatment that reduced the bacterial count by 4.5 log. That would reduce the number of bacteria to this amount, and the number of pathogenic Vibrio would become 0. There is a vanishingly small probability of illness, even though there logically with no pathogenic Vibrio you would expect no probability of illness. But remember, this is being fit into an estimated equation, so there is a very small probability that remains. But the consequence is that this person did not get sick, because the order of magnitude of illness is 1 out of every 100 million or so people. Now, what we also did in this model was we said take these oysters here and let's subject them to a freeze treatment. And we would have a 2 log reduction. Excuse me. Actually, what I should be showing you, this was my mistake, but forgive me if I don't begin this video again. I should have been down here. Instead of the 3.6, I should be showing you after freezing, or excuse me, after refrigeration. So 3.02, 2 log reduction would be 1.02, and this person consumed 2 pathogenic Vibrio. So this says the heat treatment gets rid of all the Vibrio. The freeze treatment gets rid of most of the Vibrio. And the other option here would be a rapid cool treatment. Rapid cooling doesn't have a fixed log reduction, but you can see this was reduced from 3 to 2.5, and the number of pathogenic Vibrio was reduced to 58. The person's probability of illness was just about cut in half, a little bit better than cut in half, and this person was not made ill either. So that was a lot of detail, but here's the bottom line. The risk manager needs to know that they have a risk management model that can estimate the number of illnesses under existing conditions, that's the green column, but this model also shows them the effectiveness of heat treatment, which is the beige column, freeze treatment, which is the light blue, and rapid cool, which is the purple. So this is all part of the risk manager's responsibility, so that when we talk about the risk manager's role for risk estimation and understanding and considering the results of the risk assessment, these are the kinds of things that a risk manager has to do.